Section 8.1. Our objective today is I can find the geometric mean between two numbers and use the relationship between altitude and hypotenuse of right triangles. In this section, we need to be able to work with radicals and be able to simplify them. So remember that a radical, this is the symbol for radical, and the index is a 2, even though we don't usually write that in. And this is asking us to undo squares. So for instance, if I have the square root of 18, to simplify that, I think of 18 as 9 times 2, and 9 is a perfect square. So the radical is asking you what number was squared to give you 9. And the answer is 3. So we bring a 3 out, but there's no number to square to get 2, so it stays inside the radical. Another example, for instance, the square root of 60. Well, we break that up to 4 times 15, and so it's asking you what number was squared to give you 4. It's 2. And there's no number to square to give you 15 or the factors of 15, which are 5 and 3. Neither one of those are perfect squares, so it stays inside the radical. Okay, square root of 48. Again, we break it down looking for perfect squares, so that's 16 times 3. And so what number do we square to get 16? It's 4 square root 3, right? So we are going to be using radicals to solve some equations that we want to do, okay? So we're going to start out by defining the geometric mean. Okay? And it's defined as this. If A, B, and X are positive numbers and A is to X as X is to B, then X is the geometric mean between A and B. Okay? Now notice it's called the geometric mean because notice in the position where the means would be, it is the same number. Okay, that's the key. These two numbers have to be the same. Okay? And so for example, if I want to find the geometric mean between 12 and 3. I set up the proportion 12 is to X as X is to 3. And then we do means and extremes. So we get X squared is equal to 12 times 3. And we take, that gives us X squared equals 36. Then we don't want to know what X squared is, we want to know what X is, so we take the square root of both sides. So X equals 6. Okay, because the square root of 36 is 6. So what if I want the geometric mean between 7 and 14? So it would be 7 over X equals X over 14. And again, notice that the means are the same number. Then X squared equals 7 times 14. Take the square root. So x is equal to 7 square root 2. Because the number that is squared is 7, so we bring out a 7. Okay. Alright, so that's how you find the geometric mean. Now it turns out that the geometric mean is very important to right triangles. So we have this theorem. It says, if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. Okay, so so if we have a right triangle, so this is my right angle, so this is x, y, and z, and from the right angle I drop an altitude. Okay, then that altitude forms two additional triangles. Okay, and those triangles, according to this theorem, are similar to each other and to the original triangle. Okay, so we'll say this is point A. So YA is the altitude to the hypotenuse. Okay, so that's the key. And so according to this theorem, triangle XYZ is going to be similar to triangle XAY. And that one's going to be similar to triangle YAZ. Okay? And because they are similar, we know that corresponding angles are congruent and corresponding sides are in proportion. Right, and if measure of angle YXZ equals 40, so YXZ would be this angle. If that angle equals 40, then measure of angle ZYA, this one must also equal 40 because those are corresponding angles, okay? And then that means measure of angle YZA is equal to measure of angle XYA, which would have to, both of them would have to be equal to 50. Okay, so the theorem says that the three triangles are similar, but from the theorem we get two corollaries, and these are the ones that are that we actually use. So corollary 1 says when the altitude is drawn to the hypotenuse of a right triangle, the length of the altitude is the geometric mean between the segments of the hypotenuse. Okay, so here's what it's saying. So we have the right triangle, and we drop the altitude. And so notice that the altitude divides the hypotenuse up into two pieces. There's that piece and there's this piece. Okay, so we'll call those X, we'll call this Y, and this Z. And we'll call this W. Okay, so what it's saying is that the length of XY is to the altitude. Oops, let's call this W. So WY, as the altitude is to the other piece of the hypotenuse. Okay? So piece of hypotenuse is to altitude as the altitude is to the other piece, is the way I remember it. Okay? So then corollary 2 has to do with the legs. It says when the altitude is drawn to the hypotenuse of a right triangle, then each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to that leg. Okay, so if I have triangle X, Y, Z with altitude Y, A, okay, then this is a leg, this is a leg. So what this one is saying is that for leg XY, then XZ is to XY as XY is to XA. Okay, so it's hypotenuse to the leg that we're looking at as the leg that we're looking at is to the segment adjacent to leg. Okay, so if we're looking at leg YZ, it would be XZ is to YZ as YZ is to AZ. Okay, so here's an example of how we would use that. So this is A, this is N, this is B, and of course this is a right angle, this is C, and if AN equals 4 and NB equals 9, find CN. So we're finding the altitude. So in this one we're using corollary 1. So we're doing the piece of the hypotenuse is to the altitude as the altitude is to the other piece. Okay? So it's 4 is to X as x is to 9, because this is 4, this is 9, and this is what we want to know. And so we get x squared equals 36, or x equals 6. Okay? Using the same triangle, if AC equals 8 and AN equals 4, find NB. So this one is x, and AC is 8. Okay? So for this one, remember it's the whole hypotenuse is to leg, as the leg is to segment adjacent. Okay? So the whole hypotenuse would be represented by 4 plus x is to the leg, as the leg is to the segment of the hypotenuse adjacent to that leg, so it would be 4. And so we solve that one. So we do means and extremes. So we did 8 times 8 gave us 64. So 16 plus 4x equals 64. So 4x equals 48. So x equals 12. Okay? So this length is